Okay, so I'm gonna talk about some of the things that have changed in Argyle over the last week or so. Not much. I've been busy and back to work, so no free time really to do anything heavy. Mostly what I've been doing this week is stabilizing. But I do want to talk about some concepts. So, for example, in the early days of designing Argyle, one of the things that I explicitly decided to do was to not worry about the idea of versioning of workflows or processes. What do you want to call them? These automatically generated tags. One of the things I had seen in traditional workflow engines was that you create a flow, you have to version it. Once you've started a flow, the system has to know which version that flow is attached to, and that means maintaining multiple versions of different flows over time. That's complex. That's something where it's like, well, I could put a lot of effort into that, or since I'm doing event sourcing, I could just create a snapshot of the state of the system as it was at the time the flow was created and just operate against that. So that's one of the conceptual things that I have not talked about in Argyle before. I'm going to talk about it a little bit today, and you can get an idea of what I mean. But we're now in the sort of the naked, the bare state of Argyle right now. So you start up, there are no steps registered, right? And so what you want to do is you need to register some steps. What I'm going to do is I'm going to start up a couple. So let's see. Start with order creator. Everybody knows that one, right? So if I go back to there, you'll notice that it already registered. Let me make this a little bit more obvious for you, so you don't get confused. And then so Docker compose up. Um, let's try the user resolver. Actually, no better. Notification sender. I think that's the name of one of them. Yeah, so there it is. And so when you create when you register the steps with the system, what you're going to notice is that they're not connected to each other because right now they can't be. And so I will now start up another one. Let's try Docker compose up. I will do the user resolver. And you'll notice that it's there, and bang, one of the first things that you'll see is that because user resolver has a user info output attribute, it immediately creates the connection between these steps. So now what I'm going to do is I'll start up, I don't know, Docker compose up. Uh, what's another one? I think it's called payment processor. Can't remember. I can't remember the name of all these things. Yeah, there it is. Okay, so now you get it, and you can also see that it doesn't know its state yet. Right, it's starting up. It'll eventually ping it, and it'll find out what its state is, and then it'll go green. But what you can see is that as these services are being registered with Argyle, you're not explicitly describing the relationship between the services. It is completely implicit based on the attributes. So Argyle will say, hey, I see that this has an output, this is an input, and that's essentially the way data will flow. And now, I have something complete here, and that means that if I want notification sender to be the 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 goal step, it knows the only thing that it can get based on the current configuration, because it can't get reservation since there's no reservation service, is the user resolver. So it will call that. Anyway, I'm gonna finish this by basically registering everything, okay? Because that's easier to do. So I will just call Docker compose up, and it'll register the rest of them. So there you go. There are your services, and then let's get to some of the things that I've changed, just so you can see it. So I've created a little bit more visualization in the way things are done. So, for example, if actually better here, like so for order creator, if I were to say that user info should actually be an optional, I can now describe the optional value, totally legit. And then I can also say an optional timeout now. So last week that wasn't there. It's something that I had started doing early on in the development, and then I backed out of it because I wasn't satisfied with the way it was being done. I've given it some thought about sort of like the semantics and how it should work. And so the way that timeouts work now is that for any step, if there are any required fields, like for example, in this case, there's product info, as soon as all of the required fields, attributes of inputs of the step are satisfied, then the timeout will start for the optional ones, meaning that if there are upstream steps that could possibly satisfy that attribute, it will give them some time to actually satisfy the attribute, but otherwise it will go with the default. So in this case, I'm going to be really strict about this. I'm going to say like, I don't know, 100 milliseconds. And then the idea there is you'll see the change when we do it, is that we now have moved to the optional visualization. And so you see here, that's been there the whole time, by the way. The optional path was always this orange dotted line. So there you have that. Now, one of the changes that I made from a visualization point of view in the last week as well is to sort of help developers understand the flow and how the dependencies work. So if I bring up the start flow dialog and I go and I hover over user info, for example, you now get a visualization of that attribute, where it exists everywhere, and how the connectivity between the steps actually works. So, for example, it might be a little hard to see, but here, you have this sort of pulse visualization that goes outward. That means that it's an output. Yeah. Here you have it's coming inward. That means it's an input. And then, of course, you can easily see that the lines are now animated so that you can see how the attribute flows between the steps. So that's kind of the idea. As you go between the different attributes in the dialogue, it's just going to highlight the way that the attributes would flow through the process. So, got it? Good. All right, so now I'm just going to start this. You've seen this before, you know how it works. But one thing that will change now is because we have the optional. Let's see what it is. It did optional. So, and why did it optional? Because it was a very tight deadline. And what ended up happening is that inventory resolver resolved really fast. So let's say it was 8 seconds or so. You can see 8014 milliseconds. And therefore, user resolver must have been more than that. Yeah, so it was 9 seconds, which is beyond the 100 millisecond timeout. And if I were to run this again, then the timing would be different, and we can try that. It might end up with a different result. So let's give it a little bit of time. Okay, so here it's 9, here it's 8, so it ended up with the default again. it's like playing the lottery. Hold on a sec. And by the way, the latency that you see in these steps is purely synthetic and random. The idea is that you want to see how services in the real world work. That might take a long time to actually respond, and so I make sure that you can actually see what's happening. But in the real world, if these were really fast services, you would just see things resolve like immediately. What do we got now? Again, it was the default. Trust me, folks. It actually does work, and it doesn't always default. So I'm gonna run it again. I mean, obviously, you can see product info this is the output for product info, and then you can see it as the input. Another thing I will show you actually is the fact that optional values are local to that step. They are not going to be global, meaning that it could be, for example, that another service requires user info, and that means that that downstream service will wait for user info to be fully resolved before supplying it. So here we have the default, so it did default because it was optional, and again the timer didn't work out. But down here you can see that it did get the user info that the user resolver emitted, because this was actually a required connection. So that's basically how that works. I feel like we're not going to get what we want. Let me do something. I'm just gonna change this. I'm gonna give it 2 whole seconds. Maybe we'll get lucky. So I'll run it again. Okay, so now we've got our input value that's provided from the user resolver. So you can see that the timeout system actually works. And this would be good for certain use cases. So for example, I don't know, let's say that you have some LLMs that are upstream of a step, and it basically just wants to choose the response from the LLM that came back the fastest, or something like that. So you can kind of create races, and model them in this way. Or you happen to know that a service is just really, really, really slow. It has some value, but it's not that valuable, and therefore you want to allow for a timeout, so that the overall process can continue. And this is what you would use that for. Okay, so now I'm going to go into Redis, and here's why. Actually, let me refresh this because that's stale data. Going back to the versioning thing, one of the things, again, that I explicitly decided to do when I started is like, I'm not going to worry about how to resolve versions and how to maintain multiple versions of a process flow or whatever over time, and then also have to do the job of like pruning it or garbage collecting old versions that are no longer used because there are no active instances and stuff like that. I just didn't want to deal with that kind of complexity. So what I did instead, and because everything is event sourced in Argyll, is I decided that when we start a flow, an execution plan is generated, which is just a graph at the end of the day, of all the steps that need to be included for evaluation in order to satisfy the goals of the flow. I will literally just take that execution plan and just jam it into the initial event of the flow, so that in the projection of the flow, we have a snapshot of that plan at the time that it was generated. And so even if anything has changed with the overall landscape in the meantime, it doesn't matter. It continues to operate the way that it was initially designed to. So for example, here are your events for a single flow. Flow started is the event of interest, and that's this one right here. So if I pull that up, what you're going to see, hold on a second, is I'll make this bigger if I can. All right. So what you're going to see is like you have, every event has a timestamp because that's just how it works, right? You have an event type, which is the flow started, and then you have the data of the event, which is the event payload. The very first thing you're going to see here is the plan. And so in the plan, you have your goals. And in this case, there was only one goal step, which is notification sender. But if there are more than one, then you're going to see more than one. Then you're going to see the steps. So the idea there is that you have inventory resolver that was included as part of the plan, notification sender, and so on. You're also going to get the complete definition of those steps as well. It's not just going to be the names, right? So like in a traditional way of doing it, you would probably have like the name of the step and the version that you're interested in. Then the runtime would end up having to look up the step in a catalog and know which version it needed to retrieve, which means that you have to sort of maintain these versions in perpetuity, which is silly. In this case, it just takes the entire step definition and it just keeps it as part of the plan. And the good thing about that is even if the landscape of services is completely changed, or even everything has been deleted in the meantime, the individual flow can actually continue to execute for as long as it needs to execute to achieve the goal steps. That's the idea. Is it redundant? Yes, absolutely redundant. But the point was it actually simplifies the processing quite a bit, and it also helps greatly with sort of the auditing of the flow itself. So inside of these events, you're gonna basically see absolutely everything that happened as a part of that flow being executed. There's nothing hidden in how it's done. So, for example, like let's go back to those defaults, right? With the optional timeouts, there is going to be sort of like flow state, meaning the attributes that are part of the top level state of the flow. Those are going to be like always provided via attribute set events. And so you have an attribute set, you have the actual value of the attribute, and then you have the step that set it, in which flow ID and the key, the name of the attribute that was set, which is reservation in this case. That's the idea. You have sort of provenance information about the attribute that had been set, and where it came from, and at what time it had been set, via the timestamp, of course. The good thing about that is that if you have requirements, this is where the requirements would be satisfied. But if you have optionals, what ends up happening is that the execution of the step is actually, again, it's redundant, it's copied, is separate. So let's see, step started, for example. So this is going to be the payment processor step, as that was part of the flow. And when it gets started, it's going to be provided inputs. And in this case, it's being provided the input of order. And again, as you can see, it gets a copy of the value of order. It's not relying on sort of the global projected state that's part of the flow itself, because this value could have been provided as a default. In this case, it wasn't. So let's see, maybe we can find that's product info, not what we want. Steps started. We have 2 steps started. So then the next one should be product info. Yeah, here we go. So you can see. So this is actually a work item, and you can see that the user info defaulted in this case. So it's providing the user info, even though what'll end up happening is that the attribute is going to be set with the real value. And another step that needs user info, which I think is notification sender, could be wrong about that, would actually have the full version of it. So the idea again is, yes, there's a lot of redundancy, but it minimizes the amount of like lookups that you have to do, and minimizes the amount of complexity in the system itself, so that you can reason about it more easily. And one of the things that I've found with this approach, because I am using AI pretty considerably, both Codex and Claude, they seem to do a much better job of reasoning about your code base if you sort of take a very functional, like pure functions, deterministic, no hidden state approach to doing development. And because of the choice of doing event sourcing and CQRS and a lot of patterns that are sort of just unidirectional, what I've found is that it is able to refactor and maintain the code base much more easily if it were just a big pile of spaghetti, quite honestly. I also take a very sort of functional approach to how I do Go. I'm using a lot of closures, a lot of function types instead of like interfaces and stuff like that. And it makes it, again, a lot easier to reason about. All right, so there you have it. That's my update for the week. Have a good day.